All right, welcome back, everyone. We have 8.3a, the law of sines. Now, this a here is because this is for just Algebra 2. This is where honors and Algebra 2 are going to split significantly in the standards that we teach, okay? So, if you're in honors, this is not your video, FYI, okay? Now, the learning goals here is to use law of sines to solve triangles, specifically triangles that do not or that are not right triangles. All right, so let's start off here with the law of sines, and this is going to be, an introduction here. So I'm going to start off by drawing a terrible triangle, okay? And we're going to have capital A, capital B, capital C, and then we're going to have lowercase a, lowercase b, and lowercase c. Now your angles will be the capitalized ones, and your sides will be the lowercase, okay? Notice how this is not a right triangle, not an RT, not a right triangle, okay? Which means we don't have that guaranteed 90 degree, okay? Now the other thing that you need to notice here is how these line up. The capital angle here points to the side, okay? And that's very important to notice here. Capital B points to lowercase b, capital C points to lowercase c. Now, if you think about an angle here for a second, an angle really, lines up to your side or its corresponding side very, very well. Let's just say this was 30 degrees. We're just going to say that, okay? Well, that 30 degrees would open up perfectly so that those two lines create this side at a specific distance. Well, if I increased this angle, this angle all of a sudden, we made it a little bit bigger and it was out here, we'll call it this, 45. Notice how that side here has to get longer to meet, okay? So the angle that we have that opens up to a side is directly related to what the length of that side is, okay? Now, let's bring this, boom, 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 okay. Let's bring this to our law of sines that you see here on the right, okay? So you can see we have this formula and we have this formula. They are just flipped because you can use them either way, okay? But this kind of looks weird. It looks like a triple or double equation here, right? Because we have two equal signs. That's not really what we're saying here. We're just saying that all three of these pieces are equal. So A over sine of A, B over sine of B, and C over sine of C are all equal. Okay, sorry, I had to do a quick pause in the video. So kind of back to this right here, all right? What we really mean is that I could take A divided by sine is equal to B divided by sine and utilize that as an equation. Or I could do this. Or I can set these equal to each other, right? They're all going to give me the same value because I'm relating the side with the angle, okay? Now that also, because these are all equal, right, we can flip these fractions and we can do it this way if it's more convenient, okay? So let's get into some examples. I know there's no triangles drawn here, all right? I'm going to be drawing them because they're regularly shaped. So we have our first one here, which is going to look like this, okay? And we're going to have A, B, and C. And we're going to have these right here. We're going to have 105 degrees. We're going to have 40 degrees. And we're going to have this length of 7, okay? Now, the side we're going to want to find here is we're going to looking to find the BA side, okay? Which we also, talk about as that it's little c, but we're going to refer to them also by, using the angle, so BA. So we're looking for that little c side, okay? Now, to use the law of sines, we don't need all the sides, all the angles. We just need some of them, right? We can see that this side here, C, we don't know, but we know its corresponding angle, 105 degrees, okay? Now we need another one though, right? Because if this one has the, not what I want to do. If this one has the unknown C, we need another sign with an angle and a side that we know both of them, okay? So if we look here, angle A with 40 degrees, we do not know this side. so we can't use that one. We look here, we have a side of 7 for little b, and it looks like we don't know this angle, but we do because we have two other angles. So let's fill that in, right? Take 180 minus 105. That gives you 75. And then we minus 40, so we get 35 degrees. So we know that this angle B here is 35 degrees. So now we see that we have the 105 degrees in C, and we also have the 35 degrees and 7. So we have one complete, one with an unknown. We can set those equal to each other. So I can sit here and I can say this, that that little b divided by sine of b is equal to little c divided by sine of c. Okay? So look, just kind of quick recap here, because we have all of b and we have part of c, but we're missing one. That's how you're going to want to line these up always, and you're going to have to do a combination of that, because remember, we can set any of them equal to each other, but when we do something like this, we want to have 3 out of 4 of those pieces of information. That's how we set these up, and so we're going to use a combination that gets us that 3 out of 4 so we can find our missing. If you have more than one missing when you set up these equations, it's not going to work. Okay? Now I can actually plug in those values, right? Little b is 7 divided by the sine of 35 degrees is equal to little c, which we don't know, divided by the sine of 105 degrees. Okay, and now we can solve for c. So we multiply sine of 105 to both sides. Okay, cancels here, and we're going to get c is equal to sine of 105 degrees multiplied by 7 divided by the sine of 35 degrees. Okay, now in order to do this, we are going to need our calculator. So let me just get that up here. Okay, and we're going to plug in and all that information. All right, now make sure yours is in degrees. Okay, if it's not in degrees, you're not going to be able to do this correctly. Okay, so I'm just going to, I can type mine in, sine of 105 multiplied by 7, which we'll do that, and that's going to be divided by the sine of 35 degrees. Okay, and so our answer here is that the c side is equal to 11.7883. I like to round to the hundredths. Okay, so that means that a c is approximately 11.79. Okay, now kind of makes sense, right? You could see that there's a 35 here opening up to a 7. We know that 105 should open up to a bigger length than that. Okay, but everything looks good here. All right, so this is how we use a lot of signs to try and find missing sides or even missing angles for problems that are not right triangles. Because if this was a right triangle, we could have used much different methods to try and figure that out. Okay, all right, so hopefully this is kind of making sense. All right, I'm gonna have another one for you guys to for us to do right here. All right, yeah, let me do this actually. See if I can use my tools. Just take all this work here. Hold on. See if this works. It's gonna let me just minimize it. Resize. Oh dang, let's do this. Boom. That well, it works there still. Okay. So we got another one here. All right. This time I want you to find angle B. Okay. Now I'm going to draw out our triangle. Now I know it looks like it may be an isosceles, or excuse me, it looks like it might be a right triangle or an equilateral triangle or something like that. It's not. Okay. And we're going to have the following sides. We're going to have A, we're going to have C, we're going to have B. You're going to be given that this is 63 degrees for angle A with a side of 5.5 that corresponds to it. And then we're going to get the side little b is 4.7. And I want you to find this angle B here. Okay. Now, you're going to need law of sines. I want you, man, my calculator's there. Just realized that. Okay. Now you can see the whole triangle. Okay. So it's Monday, right? It's not Thursday. Okay. So here's your triangle. All right. I want you to use law of sines to try and find that angle first. It's going to involve doing a little bit of different stuff than we did in the last problem. That's okay. Pause it, give it a try, and then we'll go over it. Okay. So we see that we're given all of A. So we know we're gonna need that one in the problem. Okay. Now for me, I'm gonna use sine on top. Okay. Just purely because I want to. Okay. So I'm gonna go sine of A divided by little a is equal to sine of B divided by little b. Okay. All right, because remember, they're interchangeable. So now I'm just going to plug in that info, right? So I have sine of 63 degrees divided by 5.5. And that's going to be equal to sine of b, which we do not know, divided by 4.7. Like that. Okay? Now, we need to solve for sine of b. Okay, so I'm going to multiply. I'm going to go 4.7. 4.7. This cancels. Let me write this over here. And I get sine of b is equal to 47, 4.7, sorry. That's a 4.7. Times, don't zoom. Okay. 4.7 times the sine of 63 degrees divided by 5.5. Okay. Now, problem here is that we have our b kind of locked away. So we need to do the inverse sine. So inverse sine here. And we need to do it to the other side. It's kind of hard to write it in there. So inverse sine of there. That's going to cancel these out. I'm going to get b is equal to the inverse sine of all of this. Okay. It's a lot there, right? So let's get our calculator out here. And let's give it a whirl. All right, so I'm just going to be typing mine in. Well, I'll use a little bit. So I'm going to do the inverse sine, okay, of everything in there. So I'm going to go 4.7 times the sine of 63. And all of that, so let me put all of that in parentheses, just so that it's very clear that it's being divided by. All of that is being divided by 5.5. I go for my answer. It doesn't want to give me my answer. Okay, let's do it a different way. Sometimes I gotta just trick it into giving me the answer. So I'm gonna go 4.7 times the sine of 63. Really? Okay. Advanced calculator, ridiculous. All right, let me just pause this, see if I can figure this out. Okay, and we're back. All right, so I kind of figured out, didn't want to give me the answer because I didn't put the parentheses around the sine of 63. Again, that's just kind of exclusive to this calculator, but I took the inverse of that whole right side, and you can see that we get an angle of 49.5883. Okay, now I'm going to write that in, but I'm going to round it, so B, angle B, is approximately 49.59 degrees. Okay, so we just figured that out for this. Okay, now when do you really use this, right? This law of sines. Two big situations here. Okay, one, we have a triangle that's not a right triangle. Okay, let me get rid of that calculator. We have a triangle that's not a right triangle. Two, okay, we have to have the right amount of information after we know it's a right triangle. We have to see one side line up where I know its angle and its side, and one side where it's missing. Okay, now if you chose to do A over sine A on this side, it might have been a little bit more difficult of a problem to do. It might have been the same amount of difficulty of problem to do. Okay, but I know that that would have put our sine B on the bottom in the denominator's place, and I feel like I would have had to do a lot more shifting around. So if I were you, if you're looking for a side, I would use this, the side over the angle, because then you're just going to multiply the angle, right? And your variable that you're solving for is in the numerator's place. It's a little bit easier. If you're solving for an angle, put the angles up top, because then you're going to multiply both sides by the sides, and your angle is already going to be where it needs to be in the numerator's place. Okay? Okay. So the next thing we need to know is that sometimes you can get two answers for a law of sines problem. Okay? And what I mean by that is let's look at a triangle that looks like this. Okay? And let's say, you know, this is A, this is C, and this is B. Okay? Okay. Now, okay. All right. So when you get to this situation here, all right, and you're looking for angle C, okay, and let's say we know that side A is 4, and we might have some other information here, but it's really important what these values are here, okay? Or even if we're looking for, let's say we're not looking for side C, but we're looking for the angle C, okay? This angle C here, all right? Well, if you look at how this triangle is drawn, it's kind of a small, you know, small triangle, right? And we would expect a small angle here, okay? A big angle here, and maybe a medium-sized angle here. But let's say you solve this, and for C, this angle here, you get a really, really big number. Well, a problem like this is called that it has a swing out. And what we mean by this is that if this length right here is 4, well, there could be another, if I put that same length 4 over this way, you see how it looks, they look the same length, right? It can meet out over here. So let's draw that. Let's do that with a highlighter. There's another triangle that exists there, okay? So what this means, right, is that if you do the law of sines and you have a small triangle like this, okay, and you know that this angle is supposed to be an acute angle, it's supposed to be less than 90 degrees, but you maybe get an obtuse. I know this doesn't look obtuse, but you maybe get an obtuse angle, okay? You need to take 180 degrees and minus that obtuse angle, and you're gonna get the actual acute one, okay? So when you're doing these, you need to really look at them and make sure that they actually line up, okay? And if we go back to this for a second here, you see that this is 63 degrees, this is 49.5. I mean, that makes sense, right? Like maybe, what's the difference between 49 and 54? Not much, right? But if I did this and this is 63 and all of a sudden I'm getting like 118, and that would mean that this is like 1 degree or a few degrees. Now you're starting to see, okay, I need to take 180 minus that obtuse angle to get the actual acute angle that's supposed to belong there, okay? Now, if you're confused by this one, you know, we're going to see this come up in the assignment, and we can focus on that in class, okay? Now, if you're in Algebra 2 Honors, you got more. If you're in Regulars, you'll have a different video at another time.